Okay, guys, good evening. Welcome back. We will continue with our Linux session. So today is day 14 Linux session, and today the date is 25th of your October 2025, and the timing is evening 6 to PM IST. So, guys, in today's session, that is in the morning session, that is the date 13 session, we try to understand about the difference between an interpreter and a compiler. We also saw how to write a simple bash shell script, right? And then how to execute the scripts. Usually there are three methods are there. And afterwards, we try to describe out whatever the bash features and try to understand each and every bash features which is available. Of course, there are more than 10 features. There are more than this, but I thought that, okay, this much is sufficient for us to understand. One thing is pending is in this is not but the job control. Okay, fine. And also we saw the arithmetic substitution. Okay. Now, this is what we had pretty much covered in today's morning session. Now, what we are going to cover today now. So, guys, let us try to learn a lot of commands, right? And pertaining to certain topics like process management, right? So we know that in Linux we have a process management. So let us try to understand the process management related commands actually. There are many commands are there, but we are going to cover only few of them. Okay, let us try to understand what are those commands which are comes under the process management. So before we start understanding about the commands directly, let us try to theoretically understand about the process management, right? So let me open MS Paint. Now, guys, we know that actually like you have something known as a user space and the kernel space, right? So we know that why we have a kernel space and why we have the user space, right? Basically, in the kernel space where kernel will be up and running, user space is a place where user will be logging and he'll be doing all his activity, right? So whenever a user logs in, you know that he will get a shell actually, and that is a bash shell. Now this bash shell itself is a process actually. It itself is a process. It itself is a process. So what is a process? What is the definition of the process, or what is the term process? So we know that process is nothing but it is a running instance of a program in memory. We call it as a process, or a program in execution. We call it as a process. So whenever we want to run any application or task, basically the operating system or the kernel has to create a process for that actually, right? So process has various different resources. It has a process will have something like a text segment, data segment, stack segment, heap segment, no, environment variables, pending signals. Those are some of the resources where each and every process holds. Now this bash itself is a shell, but itself is a process actually. And every process, guys, will have a PID. It is associated with some number. We call it as a PID. And every process in Linux will have some kind of a parent. It is not like that a process will just created as it is, right? So this bash shell would have is created with one of the process which we call it as a login process actually. So there's already a process which we call a login process. So login process is a process which actually creates the bash process. And how the login process will get created? A login process will get created with one of the other process, which we call it as a MinGT process. MINGETTY, MinGT process. And of course, who is the father of the MinGT process? Yes, it is the father is the init process. So init is a main godfather for all the process. It means that the first process which is created in Linux is init itself. So this is how the process chain will be there. And you could see that for every process, there will be a parent process and there will be a child process also. So for this bash pass process, the parent process is a login process. For the login process, who is the parent? The MinGT process. For the MinGT, who is the process parent process? It's the init process actually. Right. So it will be like a chain link always in Linux. That is what we call as a process tree, or we call as a process table. We call it as a process tree or process table. Both are one of the same. Right. Now the thing is that when the bash process is running, right, And if a bash process is running, of course, the bash process also has its own PID because of process identification number, right? And again, what happened, right? There are a lot of PIDs are there. Like in case of Linux, actually, from 0 to 65,535 process can be created, but this is configurable. You can even increase to more than 65,535. There is one configuration file is there, which is another PID.h header file is there. In that, they have assigned as a macro max PID level, something like this, 65,535, like this. In one of the file, it is mentioned like that. With that, you can understand, okay, saying that, okay, Rajesh, the the value of the maximum of PIDs which you can create in Linux machine is 65,535. Of course, it is configurable. You try to create more than this process also. It is configurable, right? But this is a max. Of course, as and when a new kernel comes up, this value will keep getting added up. Okay. Now, the thing is that, guys, whenever a bash process is running, whenever the bash process want to execute any task, or it want to execute any command, or it want to run any application, the bash process itself will not do it actually. So what the bash process will do, bash process is going to create a child process. It's going to create a child process. This is the child process we say. Okay, a child process. And this bash process always try to create this child process. So whenever assume that the bash process want to execute some application, like it has something like a a.out program. Assume that there's a a.out program where the bash process has to run this program. A user is giving an input to the bash saying that, hey, please execute the a.out. But does the bash does itself? No, bash never do itself. Bash, what it will do that as soon as a program is loaded, as soon as a user said that please run this program, what bash will do? Bash will take as an input, take this command as an input, or take this task as an input, and bash process what will do? Internally it will create one child process. How it internally creates? Because bash, it calls one of the system call, we call it as a fork system call. So basically, fork system call, it is going to create a child process. So this is the child process, and this is also like a father only, like bash shell itself. This is like a chota bash shell, a small bash shell actually. And this main bash shell, parent bash, what it does that it says that, okay, I want to execute a.out, but I have created this child process with the help of a fork system call. Okay, what the bash process will do that it'll try to load this a.out, it'll try to delegate the a.out to this child process, saying that you execute this a.out program. Like that. You execute this a.out program like this. So how the loading happens, because the bash in turn call one system call known as an exec system call. So in that exec system call, it says that please try to run this program a.out. So bash is not doing itself. It is been told to the child process to do it. It means that child process will execute that application. Similarly, if the main bash process is running some ls command, so ls command is not actually executed by the bash shell. So what the bash will do, we know that now the bash shell is going to create one child process like this. Child process. How it creates a child process? With the help of a fork system call. Like it'll execute, it'll going to call internal fork system call. Now after that, what the bash shell will do that, bash shell will say that, oh, hey, I will not run this ls command, you run this ls command. So how it does internally, it is going to call the exec system call. Exec system call will load that application or the command, everything into this child process or into this child memory. So it just execute, it gives you the text instruction to the child process that you run this program. Now what happened here in this case, now child process assigned a.out program. Here one more child process is given, it has been given to execute the ls command. Both this child process will be running. So now assume that this child process will be loaded to the a.out program. So this child process will start running. It start executing that program, a.out program. Once it completes a task, what this child process will do, that child process will send back, it's going to send the exit system call, or this child process is going to call exit, exit system call. Exit system call say that, okay, whatever the task you have given, I have completed that task. So I need not to run anything more because I have already completed this task of executing this program. Okay, it sends a signal to the bash process saying that, hey, I have completed my task with the help of a exit system call. As soon as it does it, what are the output it has, right? That output will be given to the bash process, and bash process with the help of a terminal, it displays the output to the standard output, which is nothing but your screen or the monitor or the terminal. Similarly, here also, when the ls command, when this child process or nothing but the bash child process, when it completes executing the ls command, it sends a signal. It sends a signal to the who? It sends a signal to the main bash process, parent process, saying that, hey, I completed the task, man. So by calling an exit system call, what happened that this child process is going to send a signal to the bash process. As soon as this bash process or nothing but your main process receives that signal, it understands, okay, this process has completed task. So it will take the all output of the ls, and then the main bash process is going to display it to the terminal or to the screen or the monitor or to the standard output actually. This is how internally it happens always. So till here, guys, do you have any concern, any doubts you have?
If we want to see the child process
Huh?
when they are executing the program, so we can see any the process ID has been created for this ls command, or
Hmm.
if we fire any command, then the
Hmm.
child process has been created. We can see that.
See, all these commands, Rajiv, it is so fast, it is so small execution that actually within a fraction of second and within millisecond, what happens, this program will get executed, and what happens, this child process will get killed.
Okay.
We cannot exactly see, it happens everything so quickly in the background that we cannot manage it. Say, for example, you are running some task and you are introducing something like a sleep. Something like a sleep. Okay, in the program only, you introduce something like a sleep command. Then I can see the child process actually. Because still the program is running. It means that it has called the sleep, it is waiting for the, then you can see that this child process will be there in the process table or in the process tree. That also we'll see it now. How we can see whether the child
What
process
is the
created.
role of exec command? Exec, what is doing?
Exec, what it does that it will try to load the image of this ls or image of a.out to your process, to the process
Child
actually.
process.
Child process,
Okay.
yeah. Load it. Load means actually it will replace. See what happened, right? What the child is doing. Suppose bash is doing something. Now when bash is creating a child process, now the question comes, okay, child process has been created, fine, but what child will do it? Child will do the same thing as parent is doing. Child might be executing some task, the same thing parent, the parent might be doing some task. Child will also try to do the same task. He will try to execute the same thing. It's something like a person. If I am a software engineer, I'll try to make my son a software engineer only, right? Why
Mm.
the student, my son has a right to choose his own career, but I'm just saying that a goldsmith person, he will try to make his son goldsmith only, right? Because he want to continue his family business, right? Even in Delhi, if you go, right, so many people, they open a lot of big clothes shops, and also they have a lot of kids, they'll make their childs to sit in the shop only. They train them to. So why they do it? Because it's an heritage actually. It's like it's coming from the family. Similarly, whenever shell, or sorry, whenever one process is going to create another process with the help of a fork system called the child process, so what child is going to do? Child will do the same thing as parent is doing. So whatever the text instruction where the child, the parent has, the same text instruction is even shared to the child process also. But what bash says that, or this main parent says that, okay, you don't do what I am doing, man. You just do what I want to make you to do. So please execute this a.out program. So instead of doing what I'm doing, you don't do what I'm doing. You just load this, you just take this and then try to execute that program. So that's what exec system, EXEC, exec system is getting called by the main process, by the main parent process, okay, or the parent process. It will going to delegate to the child process saying that you please execute that program or the command. So with the help of a exec system call, it loads the program into the main memory of the child process. Right? And once child process is given a task, child process will happily run that program. And once it's completed,